So here we will write the algorithm for round robin algorithm. So we will have to include essential libraries. Now we have to declare a structure with name process, and we have to define the members of the structure. PID for the process ID, PT for the burst time, and GT for total time, and WT is for wait time. And then now we will declare main function. Now here we have to declare a variable to access the members of the process. So an array of X and P. So through these variables we have to access the functions of the process. Now again I will declare essential variables which we will need to use in this process, in this development of round robin algorithm. I and J are for the loops. K variable we will need to keep informations about the processes, and this total time we will need it, and M and NM is we will need to declare the slice time for the process. So here we also have to declare the wait time and total time, and we have to declare A1 is the average time, so A1 is the average time of all the process. A2 is the turnaround time of all the processes. So now we will proceed. Here we will ask the user to enter the number of process, and then through scanf we will record the number of process. Now we have to give the here we have to give the PID, assign PID to each and every process, and then we have to assign the user have to assign the burst time to each process, and here we will record the total time. Now this means here we have a loop, and this loop has to assign PID into a process, and the user this will ask a user to enter the burst time, and here we have to calculate the total burst time of all the processes. This I will explain later why we need to calculate the total burst time of all the processes. So we have to proceed. Now here we will record total burst time, and then total time of the first process is 0. We will here initiate a variable k, and then the user will be asked to enter the slice time for the processes. Slice time means that each process should be processed in a processor for that much time. For example, if slice time is 3, so the process will process for 3 seconds. If the slice time is 2, then each process will be processed for 2 seconds, and then the processor will switch to the next process, and so on. So here the user will be asked for the process. And now before going to this section, I have explained that how it works and why we need the total time. Now we have to write a nested loop, and here if the burst time is not equal to 0, then we will proceed. It will check each process whether its burst time is not equal to 0, and it will assign the ID of that process in another variable, and it will again check whether the burst time minus slice time is if it is less than 0, then we have to calculate the burst time and the wait time and the burst time, and then the total time will be equal to the wait time and burst time, and x of I is equal to burst time. So before going to the main part of the algorithm, we will discuss this, how it works. For example, if we have 3 processes, and the first process burst time is equal to 3, second process burst time is equal to 5, third process burst time is equal to 7, total burst time is equal to 15, and the slice we given is equal to 2. So how this will work? So here if we see this, so the first process this one. So the first process is equal to id1. Burst time for this is 3. Definitely wait time will be equal to 0 because it is the first process. Time taken by this process is equal to 2, and the remaining time will be equal to 1. So this process will be executed for 2 seconds. So total time taken by the process is equal to, in CPU, is equal to 2, and remaining time is equal to 1. Now the second process is equal to, its burst time is equal to 5, and this will wait for 2 seconds, and the total time taken by the processes is equal to 2 plus 2 is equal to 4, and the remaining time for the second process will be equal to 3 seconds because 2 seconds it has been already executed. Now the third process, having burst time equal to 7 and wait time will be equal to 4, and total time execution time taken by the CPU is 6, and the remaining time for this process 3 will be equal to 5 seconds. Now this here first cycle has been completed. Now again the round robin algorithm will again start from the first process. So first process we have 1, and the remaining time was equal to 1. So remaining time was equal to 1, so the wait time here will be equal to 6. For 6 seconds it will wait, and the total time taken after the execution will be equal to 7 because only 1 second has been remaining, and the round robin algorithm should be enough, sufficient enough that it give only that time to the process which is remaining, not the total slice time. If for example time remaining here time remaining is 1, so it should give 1, not the time mentioned in the slice. So this should be the efficiency of the round robin algorithm. So here the remaining time for this is equal to 0, and this process will be out from the processing queue because it has been completed. Now second process, the second process, the remaining time was 3. So if I would like to write the burst time of the first process here, the remaining process as burst time now for the first process, and the remaining time for the second process as a burst time. So it will wait for 7 seconds, and then the total time taken for that will be equal to 7, and the remaining time will be equal to 1. Okay, no, this is not okay. So okay, no, here for the third process, which is equal to third process, so its burst time is now 5, and the wait time will be equal to 9, and total time it taken will be equal to 11, and the remaining time will be equal to 3. So I will is equal to 3. So here we have got 3 for the third process. No, again the cycle here has been completed, so the round robin algorithm again will start from the first process from the first remaining process. So first remaining process is 2, so 2 and its burst time was 1, remaining time was 1, so I will write that remaining time as a burst time, and it will then wait for 11 seconds and total time taken will be 12, and the remaining time will be 0. So this process will also exit the CPU. Only process remaining is the last process 3, which is and the burst time, the remaining time is 3. So what will happen? Here in third process, its burst time remaining process is 3, and the total time taken will be 12. Total waiting time will be 12. Total time taken will be 14, and the remaining time for the process will be 1 second. Now here at last at last we will have only 1 second. So at last we will have only 1 second remaining. 1 second remaining. So 1 second will remaining, and let's see this. At last we will have only 1 second will remaining, and the total time taken will be equal to 15. So here we have talked about this. Now we will move to the main algorithm. So when the burst time is not equal to 0 here, if we say it, if the burst time of a process is not equal to 0, for example we say that process 1 has burst time equal to let's suppose equal to -1, or we can say the burst time is equal to 1. Burst time is equal the burst time of that process is equal to 1, and the slice time of that process is 2. So burst time is 1 minus 2. So this means that this condition is true here, and so again I will explain it. Here we have a nested loop. and this is a condition. First of all, it will check the condition whether the burst time is not 0. Then it will allocate the PID to another variable p of k, and then at this point it will check whether the burst time minus slice time is less than 0 in minus value, and how it will be in minus when the burst time or remaining time of the process is less than the slice time of the slice time allotted. Then it will have the value in minus. So here when the value is in minus, here it will assign the values of total time, burst time, then it will calculate the total time, and then it will assign burst time is equal to 0, and then this process will be exited because the execution time of that has been completed. If this is not the condition, means if the burst time is not 0 and the sliced and this condition is not true, then it will go into the next section of the loop, else then it will give the wait time is equal to pk minus 1 dot total time, and pk total time will be equal to pk wait time plus m, and x dot I dot bt will be equal to xi dot bt minus m, and k will be incremented. No, here again I will show you. For example, let's suppose we have 3 processes. A quick explanation here again. So the burst, let's suppose a single process we will talk about. The burst time is here a single process. If the burst time is 3, let's suppose process 1 having burst time is 3, and it passes through this condition, and then it's come here, assign a PID, then it passes through this condition. So this condition is not true, and this process will come here and it will assign the total time, then wait time plus m. Wait time plus m, for example, this is the first time, first process, so its wait time will be 0, and now the total time will be equal to is equal to 0 plus the slice time. So this will be the slice time. Then again the burst time, here we have the burst time will be subtracted. The new burst time will be 3 minus 2, and that will be subtracted, which is equal to 1. So the burst time is equal to 1. So the remaining time will be the burst time, and it is equal to 1. So here, when again this process comes into the processing area and it passes through this condition, and then it will come to this condition where Pt is now equal to 1, and the slice time is equal to minus 2. So the result will be equal to minus 1. So this process will enter into this section of the loop, and here accordingly their wait and burst time will be calculated, and at last the burst time of that process will become equal to 0. So for example, the process 1, the burst time is now become equal to 0. When again it comes here, so it will not be this will be untrue. This condition will be untrue for this process, so this process will be exited. Hope you will understand it. Now we proceed. This is the main section of this algorithm. Now we will close all these loops, and now we will just calculate the we will just print out the calculated time, wait PID of the process, wait of the process, total time of the process, and so on. So this is how we will calculate it. So A1 and A2, these are the average time for the processes, and A2 is the turnaround time for the process, the total time it taken. So this is the whole algorithm. Now we have to run it. Now we have this algorithm. I will now save this algorithm somewhere in the in a computer. So I have an folder OS. So here I will save this algorithm with name rr.c, means rr.c with the extension C. And now I will open the app, Ubuntu app, and we'll try to run this this program. So here now I will look at this this file. Now here I have in my current directory is Fahim, and here I will see the. So here I will access the drive of this computer. So let's I have in the root directory. So here root directory, and this is the root directory. Now I will now enter into the mount directory, this one. Okay, so here cd mnt and ls. So here we have seen these two directories, C and D of this computer. Now I will go into C directory, ls, and that one is in user. So I will enter into the user. cd user. Now let's see here in him, yes, ls cdos os. No, this is our target directory. So here we should have rr.c. Yes, this one is rr.c. Now we will run this. Here I will now clear this. Clear this. Now gcc rr.c output rr. Now I will enter it. So this directory is not supported. Now I will just remove it and save it again. No, it has been compiled. Enter the number of process 3, burst time first 3, second burst time 3, third burst time 5, and total burst time is 11, and slice is 2. So this is what we have got the calculation. Hope you will understand. Thank you very much.